Alright, today's lesson is on something called mean absolute deviation. Mean absolute deviation. A lot of times it's abbreviated for short as MAD, M-A-D, just the three initials. So MAD is typically used to look at a set of data just by finding one particular point. And what that point is telling us is how spread out the data is. We talked about this in box plots. If you look at just that box with the whiskers on it, you can tell how far, how close the data is spread out. Well, this is kind of doing the same idea, except we're just looking at one number to tell us whether the data is spread out or pretty close together. So to find the MAD, it takes 3 steps. First, you want to find the mean, and then you're going to find out how far each of the data points is from that mean. And then you're going to find the mean of all those points. So it sounds a little confusing, but when you take it one step at a time, it's really not bad. So first, find the means, just like we've been doing several days in class. We're just adding all of the total data points. So we have 16 plus 24 plus 19 plus 18 plus 22 plus 21. So if you do that in your calculator, you should get 120. And then we want to divide it by the total number of data points. So there's 1, 2, 3, 4, 5, 6. So when we divide by 6, you should get 20. I'll write it down here too. So because 120, the total sum of all the points, divided by 6, because there's 6 numbers, equals 20. So that's our mean. Second thing we want to do is find the absolute deviation. What that means is just how far away each of these points is from 20. Well, another way to think about that is as if you were just subtracting 20 from each of them. So I'm going to go ahead and write minus 20 in each of the boxes, just so I can remember that I'm subtracting. Now, because it says absolute deviation, that means that I want the absolute value. So even if I subtract and get a negative number, I just want that positive number. So if you're doing it in the calculator and you get a negative number, just make it a positive. So if we have 16 minus 20, be negative 4, but we're just going to make it a positive 4. 24 minus 20 is 4. 19 minus 20 will make positive 1. Then we get a positive 2. Another 2. And then finally 21 minus 20 is 1. So that's the deviation, how far each of the data points is from the mean, which was 20. So the last step is then to take all of these points and then find the mean of those. So we need to add all of these 6 points together. So we do 4 plus 4 plus 1 plus 2 plus 2 plus 1, we'll get 14. And then we want to divide by the number of points. 1, 2, 3, 4, 5, 6. It's always going to be the same number of points as the data points too. So divided by 6 is 2.3. I actually rounded that, so we can say about 2.3. So here we can do the same thing. The final answer, the MAD, is about 2.3. So what we've just found is the mean absolute deviation. The lower this number is, the less spread out the numbers are. So because this number is pretty low, it's kind of close, it's not too far from 0. That means that these data points aren't that spread out. If we had a MAD that was much bigger, that would mean that we have numbers all over the place and that are a lot further away from the mean. A lot of times MAD can be used to compare variabilities of different objects or different data points. For example, if you're looking at the height of people, say a 7th grade class, you might find that there's a large deviation because students are growing and some haven't had their growth spurt yet. You could also look at test scores. If there's a wide MAD, that means that there are some students that scored really low and then some that also scored really high. So that's it for mean absolute deviation. Go ahead and do the next 4 on your own. If you still are confused with it, I have one more video that will walk through number 1.